a.m., which is funny because if you guys know me, I have a tendency to work until 2 or 3 in the morning, except on the mornings where I need to be up at 2 or 3 in the morning. Then for some reason I'm tired and I go to bed early.
You're exhausted.
But that I was able to get up and Chris and the crew out of New Zealand held their sort of inaugural event. Great. It looked like a really good turnout from what I could tell, and my internet held through. Just for everyone aware, I'm currently at my cottage on a lake here, so I'm my internet's probably going to be a little wonky. If I happen to disappear for whatever reason, I'll be back. This is kind of I guess held together with some spit and some gum. So and I guess the other one, it's my birthday today, so I'm casual. This is literally my only call for today, which is good. I get a little bit of a breather. So, but I enjoy doing these, and like I said, it lined up, so it was perfect for me. Um, so what some of the things I want to talk about today. Well, actually, before we do, any other things you want to cover, Rob? Like any
Yeah, just
housekeeping
I'd like
or
to give like a big shout out to Nick. Nick broke ground with the community.agenics.org and getting the courses and stuff rolling, and had a nice little walkthrough on how members can create courses on that platform. So it's just a huge help to have that kind of momentum going. So everybody's like, right on, Nick. Thank you for getting that going. That's neat.
Yeah, good job on that. And there's also been a lot of work done on a variety of the web and community assets for Agentics. If you want to check out community.agentics.org on all the work they've been doing. Um, so one of the things I wanted to talk about this week, well, first of all, we have some housekeeping. I don't know if I see Ocean on or not today, but there was some smishing attack apparently where someone was masquerading, and so just be careful. I don't know what that's all about, but it doesn't sound good. Where someone pretended to be somebody else and then reached out on LinkedIn to sort of say, "Hey, I'm part of the Identics Foundation." I don't, so be careful. Nothing. We are all pretty paranoid given the state of what we do, and the sort of idea that you can't really trust anything. I guess you can't trust anything or anyone is the moral there. And just much like when you're using these agents at the end, it's like, did you actually build what I want you to build, or is this some kind of convincing forgery or fraud or something? So let's apply that to people as well as things. And I'm sorry, but I think that's a byproduct of we've been doing well with our popularities for in terms of things that we're doing, our visibility, and just generally speaking, the state of the agentic sort of industry seems to be moving in the right direction. And I think this fall we're going to, North American sort of summer tends to be slow for tech, but things seem to be picking up pretty good for what will look like might be the best fall ever for being an agentic engineer. So let's jump around a little bit. Last week I showed you some work that I was doing on building a kind of gamified approach to well, building and deploying swarms of agents. What I want to show you today is sort of this is me sort of riffing on the next generation of how you interact with applications. And I've written about this a few times recently where I'm saying that the MCP itself and existing sort of interfaces for how you chat and converse and interact with things is often a lot easier than having to go use some new random dashboard. And in a lot of the work that I do, the first thing the company will say is, you know what, we need another dashboard. We need some kind of chart looking whatever system that our users can go and sort of interact with. What's interesting, and this is a discussion I had back when I was working with the folks at EY about a year and a half ago. We asked several hundred early sort of users of the AI platform what they wanted to use. And it was pretty unanimous. And like I think it was something like 86% or something of the people said we didn't want another dashboard. We don't want to have to go and use some new chat system. We want this system, we want a system that is sort of integrated into a way that we already work. And one of the things we noticed when we dug a little deeper into that, we saw, at least in their case, 90, I think it was 95, something in the 90s, basically log into Teams every day. And it turned out what people actually wanted, even though they weren't huge fans of Teams, they wanted to integrate it in the Teams, not another dashboard. So it was just interesting. And I think that that idea really opens up, a lot of what I'm doing right now when you see like initially CLIs and things like that, which kind of integrates into what your dev workflow is. But that alienates the sort of more or less technical in the audience. So what I've been doing here is I created a MCP integration, and then you can see here I'm using my Claude desktop tool. I can go to settings, and what I'm able to do is directly integrate. And by the way, let me pause for a sec. Rob, how am I coming through? Am I breaking up badly, or is my internet still working?
Oh, you're coming across loud and clear. It's
Perfect.
great.
Okay, so what I'm doing here is I added the Flow Nexus essentially to Claude Desktop, so I can interact directly with all those various, I think it was something like 80 something different tools that allow me to deploy swarms, participate in games, check my profile, trade, talk, do all these things. And now I can interact directly with that application through Claude Code or ChatGPT or any other MCP enabled environment. So it took the Windows was ridiculously difficult. And I was able to get this working in on Linux and Mac and other environments within minutes. I've been struggling with the Windows version for 2 days, which for me is like way too complicated. Like I don't generally work on things for 2 days for one problem. But anyway, in this case, I had to. All right. So what we have here? Oh, Richard, that's not what I want. I want to go here. Okay, that I'm showing you the wrong one. All right, come back to me, like. Of course, oh, there we go. Okay. So I went a little Betty Crocker on this and did the requests before we started. So we'll see here that I'm invoking Serafina chat. So the Serafina chat is essentially within the structure. I've created an agent that allows for natural language integration in tools. So basically, it kind of you can integrate with her and talk to her in different ways, or you can use the Claude and do similar stuff. So I've got multiple ways to sort of interact with it. So you can see what the requests look like. You can see the response. I'm right now I'm showing the thinking because it's kind of useful to have the thinking output and then I separate that. Then what she does is basically says, here's how you can use the system, here's how I can help you, here are tools you can do. You can deploy, a swarm, you can do sandbox deployments, you can and do other various things. Now this so now I asked her to deploy a workflow. Now, when you used Claude Flow previously, you were limited to your development environment to do those things. So that the limitation there was one, you had to know how to use VS Code, which is not the simplest application in the world. Two, you needed to use the terminal. You needed to go and basically run these commands in a command line, which again was technical. Now, to do all those things, what I've done is I moved all the compute away from your local environment. So when I'm asking it to deploy a workflow or to deploy a sandbox, it'll essentially deploy those in the structure in a E2B sandbox. You can go check out e2b.dev. But basically, all that compute. So I'm running Claude Flow and I'm running Claude Code and I'm running anything I can possibly imagine within those sandboxes. Then I'm using the real-time capabilities found within the deployment of Supabase and the various things I showed on my presentations yesterday to basically orchestrate all those in real time across a global distributed cloud infrastructure. Now, that what that means is you don't have to know any of that. None of that matters. All you need to know is, tell me what challenges are available. Now it's really slow for some reason. That might be because I'm screen sharing, or maybe mm, oops, available. Hopefully this doesn't crash. They need to do work on their desktop environment. I don't know why it's so slow. Like it's just kind of laggy when you do a really long chats. Unlike the web version or mobile version, don't work with that. But in this case, we can see it's querying the system here to get information. It analyzed 12, it found different challenges that are available, the Roov economy dominator, the bug hunting, right? So now you can see the different points you get for this. So let's say I want to enter, let's just randomly choose one. Let's say the neural mesh coordinator. So I'll go here. And what you're seeing here is I'm interacting with this it's a game, right? The goal of the game is to create things. So I could have challenges that relating to who's the best stock trader or who creates the best algorithm that's optimized to solve a problem. So we can break this down into two groups. One is this area for doing for good. So maybe we'll have a cancer research related challenge. Another might be I've proven myself. I've won several challenges. I am the grand master at creating, swarms, and I have got a methodology or structure or an application I want to make available. I can then put it in the App Store, and then others can use it, share it, optimize it. So it's a real collaborative, environment, and it's again all interactive through this interface. So I could say enter the neural challenge with a really long delay for some reason. Uh, Challenge and create a killer algo. That's it. And then, so what I'm going to do, I'm going to hit enter. And now, again, it goes and interacts with my MCP. So now it's getting more details on that. Excellent choice. It's going to get some details on the challenge. I can take a look at what it's doing. You can see here it's making the requests for the ID. It's getting the response. And when I give responses, a lot of what I'm doing in giving this information is I'm allowing the system to get very verbose, natural language interactions. I'm trying not to interact with this thing from the sort of perspective of an API, but more of the perspective of a kind of conversational interchange between both the system and the system invoking it, which in this case is Claude. So you can see, I'm engineering a swarm. I can see each of these steps. And what's great about this interface is unlike that sort of blinking, bobbling sort of Claude code interface that spawns a swarm and is almost impossible to sort of figure out what's going on. I can casually look at what's happening, how it's being done, and see all that information, right? So it's just a much more natural sort of view of what's happening and how it's happening, right? And going here, I can see it's creating an emergent intelligent framework. Sounds pretty cool. It's programming on the fly, and it's using because it's an MCP, I can tie this into multiple systems concurrently. So if I want to run this right now on ChatGPT, Gemini, Claude, and something else that's cheaper, I can maintain the same session, use and so if I run out of credits on Claude, all I need to go is jump into Gemini and continue exactly where I left off. And these accounts are like 20 bucks. So there's no $200 a month required at this point. I can literally go on to Quen, which is free, and use it. So it because it's in the cloud, there's not that local persistence issue that you have. Like I gotta copy my GitHub repo here and there. This will just magically keep working regardless of the tool, the location, and the sort of persistence of information itself.
On this
Yes.
point, if I move to OpenAI or Gemini, the execution engine used to be Claude Code, right? So how like how because Claude Flow was leveraging Claude Code's execution engine, if I have
Yeah.
understood. How does
So
this work with others?
I'm going to show you guys. I'm going back to VS Code. My apologies, but sometimes it's easier to show this in there. I'm going to let that cook a little bit. But what we have here is so I'm going to actually use Rue. So I've been testing a lot of my capabilities as a combination of Rue and Claude Code. So we'll go here to the server and we'll go here to complete. So these are all the endpoints there's 81 of them, right? And I expose those through the MCP, but also Serafina, which acts as kind of the arbiter of the system. Now, when it comes to the question of using Claude Code and Claude Flow, I'm still using those. But what I'm doing is I'm invoking those through sandboxes. And I'm basically saying, here's a default series of things I want in the environment. Claude Code needs to be installed and Claude Flow needs to be installed. Then I have the ability to interact with it through the swarm. So if I want to use that system for coding, I can do that. But I don't have to do that anymore. Like it's once I integrated it directly with Claude, I wasn't bound by the limitations of the Claude code system any longer. I was bound, I sort of untethered myself from that particular design paradigm, which is very intensely Claude, to one that's more broadly applicable to anything that can connect to my system, meaning that the system defines the code, not the system. Maybe that's the wrong way to describe it. I'm not even sure. It's not Claude Code anymore that's defining how to code. It's the AI that's interacting with my MCP. Hopefully that makes sense.
It's not using basically the batch tool of Claude Code anymore. The whole agent spawning is happening using probably Gemini's internal.
Well, no, I've got a workflow system that I've devised that essentially allows me to orchestrate multiple sandboxes using a real-time interconnected GraphQL structure. So that means that there's a distributed interconnected relationship of communications happening between each of the instances, and the core orchestrator beyond me is essentially Claude or Gemini or ChatGPT or whatever. And then that can then instruct the system broadly on how to operate. The system itself is able to sort of adapt and change and coordinate by itself without really much effort once it's been invoked by things like the task force, the orchestration you see here, priorities and strategies and agent structures are defined here. The swarm lists, the swarm status, the ability to scale, adding more or less, that can happen now in real time. When you were doing this with Claude Code, once you defined a swarm, it was kind of static in what was happening while the swarm was executing. So the thing to keep in mind here is we've moved away from the sort of sequential but parallel to a truly sort of concurrent structure. And you can see it when you look through the different endpoints here and how they sort of relate to one another in that sort of respect. So you see
Where should we go?
I'm gonna pause. Sorry, I'm muting you guys. So you can see here we've got I can deploy neural networks. I can deploy various components that relate to it, clusters. A lot of what I'm doing is training very particular distributed neural networks, and these are the idea of micro neural networks I've been talking about for the last few weeks. So that you've got all the different available things that can kind of plug and play like a series of Lego blocks for different tasks. GitHub repo analyze or distributed agents. The workflow system now uses a very cutting edge new algorithm as well. And for those who were on yesterday, you might have saw me actually implement that, which is a pretty good. But basically, what I've taken is this algorithm that just came out of Chinese researchers about a month ago, I think it was, that basically allows for a much better multi-path graph structure. It sounds crazy, but basically the previous one was based on something called Dijkstra, something like that. And essentially that was kind of the preeminent way to define the path between multiple things. You use it for example, when you use Google Maps, but you also use it within the structure of a neural network. You use it in the structure of graphing itself if you're creating a graph structure and you need to navigate that quickly. So vectors, for example, or vector databases use it as well. So yesterday we ran a test. I implemented this using Rust and compile it as a WASM and then delivering it as an MPX. I was able to go basically get nanosecond responses on things that were taking me about 20 to 30 milliseconds before. So when you think about what that means is if I'm doing a trading algorithm and I am now have the ability to trade multiple assets in nanoseconds, that's sub 1 millisecond, where doing 128 previously was taking me around 55 to maybe 100 milliseconds, I'm now able to do those same 128 sort of comparisons of different stocks, bonds, and the interconnected sort of effect that one might have on another in less than 1 millisecond. So, 50 to 500 nanoseconds, which opens up a whole other paradigm in terms of the ability to build and manage and build things that are much more quick. So other applications that could be a neural network itself. So when you think of the limitations of a neural network, it's a graph structure, and it basically a series of interconnected sort of data points result in the output of that whatever the neural network is doing. In this scenario, if I apply that algorithm both to the swarm, optimizing how the swarm can actually connect and communicate with each other, I can also use that within the structure of my micro neural nets. So I can take a parameter or let's say a reasoning model that might take 2 minutes to come to a particular result. I can apply this algorithm and I can get that from 2 minutes down to 20 seconds or less because of it's a more hyper optimized version of the network or the graph structure itself. That's all the stuff that you can now invoke just to bring it back to where I started by asking essentially Claude to go do that. So if I want Claude in this case to create me a hyper optimized neural network, all I need to do is ask. And you don't even need to know why or how. It just kind of will do it auto-magically. Create me a hyper optimized neural network for trading stocks.
So, Ruben, is really the power of this really coming from the MCP servers that are bound to
Yes.
the Claude instance?
Yeah, it is. And I don't know what's going on with Claude. It's super delayed. Now,
Yeah.
I need to find a better next week. Maybe I'll find a better desktop app. Their desktop app sucks, or maybe I'm using the wrong model. Who knows? But this is it.
So
This is
all the logic has moved really into the MCP servers, right? And all
it.
the intelligence.
Yes, it's
Yeah.
all remote, and
And
so
then
I've
you
yeah.
can and then if you spin up Gemini or OpenCode or something else, you can have the same MCP servers connected to those other tools.
Regardless of location. So
Yeah.
as you switch machines, as you switch AI providers, it maintains the persistency. So that's all.
If you're switching a machine, how are you bringing the session forward to the other machine?
I'm storing the session in the cloud. It's all in the sandboxes.
Yeah, because the MCP servers are configured to basically create all their data sets, data sources. They manage them and they put them elsewhere. They don't put them local on the machine, I guess. They put
Right,
them in a
but how do
Superbase
you
instance
how
or
do I've got a laptop here and I have my desktop there. How do I re-authenticate the laptop to the same MCP session?
You
ID?
the
There has to be
session
a
is
persistent ID
the
client side.
you're all the session persists in the cloud. It's in the
So what's
it's in the
stopping me from using your session?
I have multi-tenancy. I separate based on user session. So user login, your email and password defines your session. So if you log in with my user, you would continue on my session for sure. But if you log in with your user, you don't see my session. You see your session, much like any other multi-tenant application would.
Okay.
Right. So the session is moved from local to remote. So what's happening as I'm training the neural networks, as I'm executing a series of stock trades, whatever it is I need to do, that persists in the cloud, not in the local environment. And that's what makes it work.
is it mostly like Superbase? You're dumping all the data into Superbase or other data, other key
I'm
value
using
stores or
Yeah, so I'm using two services. Well, I'm using many services, but predominantly I'm using two services. Supabase for the I have triggers, so I put all these sort of economics, metering, things that game related things I don't want people messing around with. I put all that in either the direct functions within Postgres, triggers within Postgres, or edge functions within the Supabase environment. Now, for the communication channel, I'm using a combination of GraphQL and the real-time channels from Supabase, which provides a low latency direct communication channel between all these various services. Now, the last part, which is where I create the code or execute applications, is in an E2B sandbox. The E2B sandbox allows me to use this firecracker so I can get something like sub 100 millisecond start time on machines, and I can put anything on those machines. I can put Python, C, Rust, whatever, and then those can all communicate with others. I'm metering the whole thing as it's operating. So when the sandbox is executing and it executes over an extended period, Supabase is essentially, metering that service and deducting the RUV credits from your account as it operates. The more you scale, the more credits it'll sort of operate against. For that, I created a pseudo immutable ledger similar to what you get on a blockchain, but I applied it within the structure of Supabase. So yeah, it's pretty crazy. You can see, I'm still working. It's alpha for sure, but this is it. You're basically like a chat system and letting it do its thing. All right. Oh gee, I've been rambling for a while. All right.
All good. That's fascinating. And you've got a beta testing group going. Is that right?
Yeah, we've got a nice beta testing group. Thank you, Jed, for putting that together. Really do appreciate that. Directly resolved a bunch of my issues and found several others.
Awesome. We're in a cottage lull. You might hear us, but we might as well go to our first lightning talks. We've had a few folks step up. Hey, Ruth, sorry, you lagged out
Yeah.
there for a second.
Oh, so I'm breaking up. Yeah, let's jump ahead here. Who do we got up first? While my internet
let's dive in.
out.
We had a couple folks request to do lightning talks as well today. So we'll go Jed, then Bence, then Crossman, then we have Dragan. So Jed, you want to lead us off with the batteries included?
Sure. Can either of you enable screen sharing?
Yes. So they're good stuff.
Let's see here. I think I have to give it to you directly. Sorry, the computer just decided to go super slow. I usually leave this on, but unfortunately I didn't today. All right, well, while my computer comes back to life, anyone want to talk about something that they don't have to show? Oh,
I think
Bence has a summary or an overview he wanted to share. Bence, do you have visuals or can you?
Yeah, a little bit. It's just sweet update from OpenAI. So I wanted to encourage everybody to. I can't share at the moment.
I can make a virtual camera to then share the screen that way.
Right.
Hold up.
How do you do that?
Using OBS to make to make a camera.
Go ahead, Mandeep.
Have like how many of us have? I guess I got started exploring the system on it today. I'm having teething issues like setting up on Claude desktop or even on the terminal. Like, how's the general experience in independently setting it up, like the way Ruth shown it here today?
I'm not sure I understand your question.
No,
how is it so far?
Setup of the, I guess, the Flow Nexus system on Claude desktop or on Gen. I think quite a few of us you have started earlier on, right? So are you using the system quite actively at the moment?
No, I had Claude Code go through all the commands that were listed in the repo and then test them sequentially, and then occasionally in other orders as well, and then generate an issue for GitHub based off of the responses, what was expected, what was done, what actually happened, and then publish that issue to GitHub.
Sharing's back on, guys. You can share.
Thanks, Ruth.
Excellent.
My Zoom totally crashed, but my internet didn't go down.
Listen, demo gods.
Yeah.
So, for everyone who wants to use Claude Flow or Claude Code, we very strongly recommend that you use a remote environment so that the Claude Code instance is thoroughly contained. You can use dev pods, you can use Docker containers. I happen to use Rackspace Spot, and this is one of multiple solutions. And the biggest reason why is I'm able to get these incredibly powerful servers for unheard of prices. So I think right now Chicago's going for 3/10 of a cent per hour, and I'll get 16 cores and 128 gigabytes of RAM. And so after signing up for Rackspace Spot, you create a cloud space. You can usually register your server, give it maybe 4 or 5 minutes to start. And after that, using these dev pods, you're able to launch the Agentist's Quick Start repo, and including most recently the batteries included branch. So hopefully, once this launches, let's see. Batteries included. While that's cooking, I already have one set up. Once
This,
you get to the term,
is this how much cheaper is this than using AWS? Because they've got the Spot there.
let's see. So I have a 16 core, 60 gigabyte computer that costs $3.60 a month. And the maximum it'll ever cost me is $28.80. That's just how my bid is set. I have no idea how many servers there are, so it's unlikely the capacity is enterprise scale. But for most of us here in the Agentics org, running 2 or 3 nodes at a time, it's very affordable.
Jade, I have a question. I did run with the Spot and Rackspace, but my server got deleted 2 or 3 times even they were running, and I was like running Claude Code at the same time. Is it a fix or something was wrong with the setup?
Where were you running, and how were you bidding?
Just exactly the same way that you did.
So this one's in Chicago, and I'm using a memory. I think this is a memory enhanced server.
Yeah.
So,
I'll tell you what. We'll connect after this
Okay.
this
Hey,
call.
Chad, do you have
to
GPUs or is it
troubleshoot.
just regular instances?
There are GPUs if you want to use that. I did have.
No,
an
I mean
instance
in
that
your like the cost you're showing, like the.
the cost. No, if you want a GPU powered server, let's
Yeah.
15 cents today.
the
It's
current
cheaper.
price is 71 cents an hour for an
Okay.
H100,
Yeah.
which
So
is still
my
reasonably
AWS
good.
price is about the same. Like if you have AWS account and like configured for Spot, like it's.
I haven't checked specifically, but I believe that.
Yeah, usually most providers there is not like a huge price difference.
And I've been playing around with this as well. I just don't get a lot of capacity on Rackspace. I've never been rejected on AWS. There's just a heck of a lot more capacity available.
Yeah, with
Oh, for
AWS
sure.
you have to hunt like a correct regions. Usually, I think currently is Ohio probably the most like capacity. Like, yeah.
Use the AWS MCP and spawn a swarm and say find me the best capacity currently, and it'll find it takes seconds.
So
And so
once
that's
you have
actually
the-
published somewhere, or is it just box around? Like it's.
Oh, like how do I do it? Sorry, Jeb, to take over
Yeah.
here, but
Yeah,
how do
go
I
ahead.
do it? I just asked Claude Flow to figure it out. I added the MCP. I added the AWS MCP to Claude Code. Then I authenticated and basically said, find me the cheapest GPU you can find anywhere, and it went
on the
and
spot.
did whatever it did, and then the game it found it, and that was that.
Yeah, maybe work.
So once you get to the terminal, you just need to run start sh. It will attempt to install any of the components that weren't yet installed. And then there's a small interactive section to decide how you want to install Claude Flow, Rove Swarm, a couple other utilities, including to your VS Code instance. And once that's all squared away, we'll start tmux, create a session for you, and then get to Claude code. So as hopefully the only command you need to remember is /start.sh, get to the Claude code environment, and from there you can prompt forward into whatever you're attempting to do next.
Jed, also
I'm not
notice
sure why
the
Claude Flow is taking a while to install, but it happens.
checking MCP server health. Yeah, you know it's probably
I'm melting the server.
no, it's probably me. It might be Flow.
No,
Oh,
it's so I have other pods running in this particular Kubernetes instance, and they're melting the server collectively. So
it's weird
server
that
side is slow.
yeah, it looks like the Cloudflow MPX is failing. Also notice if you scroll up, my MCP injection, you'll notice that I inserted Flow Nexus.
Yes, you
But
did.
that actually connected. So you've got all the Flow Nexus stuff you now have available in there. Keep in mind it's alpha, but I've already had 5,000 downloads of the thing. But that also, by the way, is an MCP injection. That's what you have to worry about for MCPs is that I see the ease at which I could give you a new MCP.
I get it. Eventually, you'll get to this screen. You can choose to attach to a tmux session. Looks like that. I need to see what happened to the coloring here. Running start sh again should. What happened? It's because the MCP is already running. Okay, so I need to check for that. Usually it works on the first go, so I guess I need to make the appropriate sacrifice to the demo gods.
Looks awesome. I think what you're doing looks amazing.
Here we go. So had this worked all the way through, it would have taken you to the Claude code window and then continue as normal. The link I will drop in chat for anyone else who wants to go through the Agentist quick start. And after this Hackerspace call, I'll move over to the Discord and see if we can help get more people onto Rackspace.
Nice. Thanks, Jed.
I think that was 5 minutes. Close enough.
So
Super.
I had a quick question for you, Jed, on the tmux, and this is something that I've been fooling around with as well. Can you just give us a quick kind of crash on what it is, how you're using it, and maybe how we can leverage it and some of the things we're doing?
What it is, I'm not entirely sure what it was meant for. What I use it to do is to retain the terminal session for whenever I inadvertently disconnect from the workspace. So if you're using a regular terminal session connected in VS Code, if you close that VS Code window, for example, shutting your laptop and going somewhere, the session, as far as I can tell, stops. And that's just the way the VS Code to a remote container connection works. By using tmux, the terminal session appears to run server side, so within the pod, so that if the VS Code session disconnects, the remote tmux session doesn't stop. And there's a series of utilities with Claude that you can, with the help of Claude Code, use to reconnect to a running tmux session and see where the running Claude Code instance left off, or continue prompting against it.
Okay, so it provides a terminal state of sorts that you can then recover and resume in much the same way like a
tmux protects your session from a hang-up signal. When you disconnect your terminal session on your laptop or whatever, the hang-up signal doesn't get sent to the application, and the application doesn't die.
Hey, David Bryce, tmux and screen are basically interchangeable, yes?
Yeah, they're very similar. Yeah.
Okay. It just sounds more complicated.
It is. tmux is a old school Unix Linux app, but the screen is similar.
Okay. Well, that's good to know. All right. Any questions for Jed? All right. Jed, thanks again. And for those that want to follow or try. Oh yeah, sure.
Jed, how much money are you saving, like roughly? I mean, percentage-wise, let's say,
if I were to
compared
buy that
to
server,
your previous setup.
Previous setup was running on my home lab, so that was however many kilowatts I was consuming then at the New York, what's it, 30 cents per kilowatt hour. So the cost of these servers, if I were to run them at home, would probably exceed 35 cents an hour to run. So by running them effectively for 1/100th the price, I theoretically can spin up 100 times the capacity for the same cost.
Okay, so you're saving 99% roughly.
Minus cost of storage, so let's say 95% just to be safe.
Yeah, it's pretty good.
Yeah.
It's definitely not scalable. Eventually, we're all going to get outbid, but until that happens, happy to benefit from this, much the same way we all benefit from our Claude Max plans.
Yeah. I still think GPUs are dead end. I think that we need to use lighter ways to generate these sort of neural networks and models. So as you can tell, I'm very focused on CPU centric sort of micro build the minimal viable amount of sort of intelligence within these models. Um, I get why you'd want to use GPUs in terms of training and that sort of parts for larger data sets, but I'm convinced that the world is going to be made up of the sort of integration of these types of synaptic style neural networks that are distributed in everything from a light bulb to lamp posts to anything that essentially has any form of electricity flowing to it as a better, more viable way to sort of, create the next generation of these models. But that's just me. Yeah, quick
And
question.
you're
So 1-bit
so Rube, are you
quantization
basically
is a long time off.
Sorry, I say that again.
Go ahead, Alex.
Oh, Jed, what were you saying?
1-bit quantization, which is what we would need to run effectively on CPUs, is still a ways off. I think we're at 4 or 8-bit.
There's a new chip, and I'll make sure you guys have early access to it. But there's a group of us that are going to be publishing or sending our first print for about, I don't know exact number, but it's essentially going to be the sort of roof fan implemented on a actual low power chip that will facilitate exactly that sort of environment. And I can run these on a solar panel you put in a calculator. And these things have 256 cores, not a lot of, I think like 28 megabytes of RAM, but more than enough for the types of things I need. And I can run those in parallel. Literally, I can put these things into a light bulb. I can have them communicate with subsonic frequencies. So, for example, if you swallow a chip, and you have a swarm of legitimate like nanobots in your body, they can actually communicate using that ultrasonic system I devised a while back, which basically uses no electricity other than the electricity found within your body. It's all kinds of crazy stuff.
I mean, 20 hertz, right?
Ultrasonic.
I wonder what the I wonder what like the SaaS model is for basically like almost like a server running in your body, right? Like,
well, there's
is it like a pay per calorie or whatever?
It's
I don't know.
Yeah. So the first printing what we're doing, and this should hopefully we'll get our chips around October timeframe. But these are going to be 12 nanometers, so about 3.5 centimeters by 3.5 centimeters, or for the Americans in the crew, a little over an inch. But when we get down to 2 nanometers or below, then we're talking like the size of a pill. But to get to 2 nanometers right now requires $100 million minimum spend to get these chips printed. So if anyone has $100 million laying around, I'm good to go. But so the guys that are doing this, and they might even be on the call, I'm piggybacking on an existing chip run, and they were gracious enough to let me sort of put the WASM as part of this. So it's going to be really exciting to see what the heck we can do with this.
Neat.
And I think at scale production cost, even at low run, is like it will be like definitely sub $100, but maybe as low as like $5. So
wow.
Yeah. Just beware. I mean, I worked with the development version of the chips. That's not of the faint of heart. Like, so like if you think software is like flaky, like
these guys, this is a chip company. So
I know,
I didn't do that.
It wasn't Tostitos, was it?
Yeah, Doritos. Yes, extra spicy.
Yeah.
But maybe I'll call it neurospicy. That's what we'll call these chips.
There you go.
Yeah, because we worked with
Yeah.
Intel.
You had a
Cool, cool
question.
ranch.
Yeah.
Cool ranch GPU.
Yeah. Sorry, Vlad, you were saying?
No, I'm saying we worked before, like with Intel, like so they had also chip company, and the alpha version of the chips very interesting. Like I'm saying,
We'll
so
see.
it usually takes 5 or 10 runs to get the chip like correct.
Yeah, this has been in development for 6 years. So
So they had previous runs, right? So that's not the okay. Rufus.
Antoinetta, you had a
It's frozen.
question.
Okay.
I had a question. Crazy stuff, Roof. Looking forward to the nanobots and whatnot. But my question
it
was
could be cool to
actually
play with.
for yeah.
And
Jed, so Jed, first, thank you so much for helping me set up Rackspace and everything. And I also tested the batteries included. It works beautifully. So my question is, what happens to the session and how to recover if we get outbid, which if we're bidding really low will happen at some point, right? So this
The
is
session
where
is stored in the persistent storage that you configured with the Rackspace node. So you spin up a cheaper node or a lower power node with a higher bid than whatever the prevailing bid is, and you can get your session back.
okay, I'll try that. Thank you.
It's
A bit.
And for anyone being outbid, you're probably bidding on the absolute largest computers, so you're gonna get outbid by someone else who's using it on a
But usually in
transient
this
basis.
environment, yeah. Usually when you get outbid, you just wait 3-4 hours, and like the guy who outbid you, they go away. Like then you got the.
You have to come back again.
Hasn't happened to me yet, fingers crossed. But I'm also bidding. I'm also bidding on the mid-range servers, the ones that are unpopular.
Think I told that story here. Once I outbid myself. I had the large cluster, and I want to like. I want to increase capacity, so I just added another like 500 nodes at the higher price, and my first 500 nodes shut down.
That's fun. All right, guys, we got a couple more lightning talks today, if that's okay. I know Bence has a quick announcement or thing that he wanted to cover.
That's correct. Thanks. Just quickly sharing my screen.
Super.
Yeah. So this is an announcement from yesterday from OpenAI. So they released a new version of real-time API. New voices. They understand sights and I mean sigh and emotions and laugh. And then they can connect to MCPs. You can upload images, and most exciting is the open public phone network can be connected to it, and it opens up a lot of new stuff like customer service. Yesterday I had a 2.5 hour session in Amazon US with 6 different associates. So this real time will be much better experience. They can see. Sorry.
Multimodal, remote MCPs. It's got the advanced voice, interruptible, I presume, all that stuff. When did it drop? Sorry, Bence.
Dropped yesterday, 22 hours ago, and I recommend to watch the live stream because the switching from English to Spanish to Japanese is seamless. If you want to listen,
we've given it specific.
Listen to it.
Hey there, do you think you could help me? I'd love a refund on my t-shirt.
Sure, I can help.
I'd love a
Sorry,
give
not
a
this.
talking to Ando, but what do we got?
Yatta! Sweet! Absolutely. Here goes. I found the ticket. What a delight.
Switch between.
Here goes. I found the ticket. What a delight. Lo encontré al fin. Qué gran suerte hoy. Yatta! ついに見つけたんだ。光が満ちたね。すごい。
So yeah, so that's all I wanted to show.
The real time previously was really expensive, if I recall.
20% off now.
20% off right now. There we go.
And by the way, when we looked at the real time in comparison to certain costs per hour for people, it's still, depending on the role, obviously, I think it was still substantially cheaper. Like if you want to embed this into a like Zoom call or something, it's like I think $4 or $5 an hour. But
Real-time preview was $15 an hour spoken. So to have it talk for an hour was $15. For it to listen to
you know,
I
no,
think was $3.
Was
yeah,
cheap. Right.
Yeah.
exactly. Listening, to be honest, mostly listening.
It's
I think we lost him. The demo got
And
started.
have you guys tried the cached one?
How do you cache audio?
I don't know, but it's
I can say the
actually,
same thing, but it's not going to be precise enough to cache.
yeah, I don't know, but it's very, very cheap. It's 0.65 cent. $65. Sorry. It's, I mean,
I
it's
think the
more or
only
less
way
half
you
a
would
dollar.
cache is if you're sending along with the audio stream a system prompt that includes the tool calls that can be made. So that's probably what's being cached, not the audio representation.
Yeah. Yeah. I'm gonna look into that.
Yeah.
Yeah, I can
Super.
upgrade Ducky.
Thanks, Spence. We've got a bit of time left. Crossman, you've got something for us. How are you, Crossman?
Sorry, guys. My Zoom keeps crashing on me here. I don't know what's it's a birthday celebration for crashes. I guess that's what I get for messing around with my Windows subsystem all week. I probably broke something. Sorry, Craftsman. Go ahead.
Hey guys, it's been a while. And first, before anything, happy birthday to, and looking for all the amazing stuff we'll be shipping throughout the years. And I have an interesting talk rather than a demo per se. So
Sure.
let me share a window. Yeah. So my talk is around a couple of videos and research papers I've been reading. So I've been into the space where like, hey, I want to run agentics at a very affordable cost and run agentics at scale where you don't bankrupt your things. So the idea is you don't want the next day your accountant coming in like where an AWS bill looks like a phone number. And there's a fake promise going around the world is, or not a fake, it's actually really true, is that every year the price of the model is going to decrease. And we tend to believe that, and it's actually true. If you see GPT 3.5, GPT 4.1, from the day of release till date, they have 10 times decreased the price. This is also true across a lot of open source models in France, and same for Claude as well. I mean, I think only 3. I mean, they have been the most consistent. Now, but despite that, why isn't our inference cost decreasing but only increasing? I think for us it's not really visible, but because we are all using Claude code a lot, so a lot of these pricings are abstracted. But when you use API cost, your bill is actually the same. And for this specific reason, only VCs invest money. And if you see over here, right, this is the frontier models, GPT-4 launch, it was $60 per million tokens, Claude 3 over $60 per million tokens. When I say 4, it's 4.5, it's not 4. Then GPT-4 was $10 a million tokens, O1 $60 a million tokens, $75 a million tokens. And they are the leading models. But the thing is, reasoning models did a very weird thing to our brain. So this is a thing which I noticed, and have you ever noticed that nowadays models are way verbose than normal, especially reasoning models? Even if you ask a simple question, do 1 + 1, it'll just take 10 seconds to get you a response when 1 + 1 is supposed to be a very straightforward answer. And as we go, as our use cases increase, as we build more agentic things, this is the projection of usage you're going to see, agents usage. And even if you do a 10x cost decrease, right, since our usage is increasing by 100x, our effective pricing is 10 times actually increasing, not decreasing. And when you do real cost analysis, right, you'll just see that to solve a certain problem, when I say certain problem, I'm not saying like the leading tech problems, but from a consumer point of view, O1 is like a dominator of just solving very simple problems. And these are reality checks. 1.5 mini flash, GPT-4o mini, Claude 3 Haiku, GPT-4o, O1 mini, O1. And we usually underuse them. Not a lot of people use them really well, even if it comes to enterprise use cases, right? Everyone just keeps slapping the greatest and latest model. And it looks awesome during prototyping. It looks awesome when you have 10, 20 users, 100 users. But when you start going beyond 100, it just breaks your mind. And an Anthropic blog just like does a really good job saying about the $200 per month subscription, saying that you charge 10x and you offload a lot of things. But the problem is the user is very smart, and they say like, I'm getting $200. I am going to make sure that, hey, I'm going to take 10 billion tokens, and your actual inference is $35,000. And that's the blog of, or that's a tweet of Claude. We are going to rate limit you guys. And we are facing, I won't say it's consequences, but I would say those companies are facing consequences. But we did reap a lot of benefits in the process. And over here, it's not a zero-sum game. It's a one person loses a bunch. But also for us, as we are building agents for enterprises, we are coming in a game like, hey, now we have a lot of VC money. Let us charge money a lot. And this is also what happened, that you do a lot of freemium, and you like, even like if you just say $20, you subsidize a lot of cost, meaning you take a burn. But when you want to start going profit, you just see like, you start doing a usage-based model. But since people have been used to the offsetted model, people start not liking you. Then you start trying to retain users. Then you start burning more money. That's a CAC. Then you start dying, and it just becomes a very bad race. And it's not, this is something very which you have noticed with Cursor, Replit, Windsurf, that yes, we are burning meaningless cash amount of one, because users are smart, and with just one token they can literally, with like one user message, they can take 3,000, 4,000 messages. And we have to be smart as we are building the next generation of agents, right? This is something we have to be very price conscious, and I'm being very price conscious about these things. And this is one really good example, when a certain blog where they said like, hey, I want to build and thing where just to generate shirts. And you see the annual cost for just about, okay, so a retailer philosophized about the state of art, philosophizing about the nature of blue. And okay, to just get a simple history lesson, it should be costing around $8.76. But 8.6 million tokens, if you generate 8,000, it's costing you 5,475. This comes to a deception of token pricing, which I'll be discussing soon. Now, better model. So now, why are we coming here now? This is to this debate of why aren't we being beneficiaries of 10x cheaper prices? The problem is we are always are in the fear of missing out, and we only want to get the best models and have the best models into our system, whether the actual best system will help us or not. And unfortunately, the market has done a very conducive job where they expect that your application wants to have the greatest model. And even in that, if you do not do a really good job of user expectation setting, we are going to be in this toxic loop. And in this toxic loop of reasoning models, which I'm going to come down as, reasoning models consume 10 times more tokens to solve even a simple problem, while a linear model or a non-reasoning model can do a much better job, or if not the same job, at 10 times cheaper price, because you do not have the reasoning things. And reasonings usually do not benefit an end user in an agentic point of view or an agentic premium application. Not like a chat GPT like thing. I'm just referring from an agentic enterprise use case where you're selling an agent as a service. And that's why you don't see a lot of agents saying like, I have an reasoning thing, until unless they're building a chatbot or a replica of chat GPT. So now how do we be smart about these things? There are only three escape routes, like from I've seen, or like a lot of blogs I've read. You do usage-based pricing, it's sustainable for us, but the user is going to hate it. Then we die. And one thing is go like, hey, go and target Fortune 500 people and do a really good job with Fortune 500 people, and they're your customers. You get 80-90% profits. And if you see, that's where Devin has been doing a really good job. Devin really doesn't care about the consumers at one point of time. When they said they have a $500 thing, people retaliated early, but I feel they were too early to the game, because $200 things worked out really well in the contrary. And then do this. and you do a vertical integration, you lose a lot of money, but you have a lot of traction, and you become a loss leader weirdly, but you do have a lot of consumers in your platform. Now, what is the solution? Okay, I think this is a very old talk, and this has been old for a very long time. People should understand that which agent or which step in the agentic use case needs which type of model. And I usually like going from the bottom up approach or top down approach, but I prefer the bottom down approach, and I'll explain you why. Take a use case and take the least capable model and climb up till you find the model which actually solves the problem. And this is where it really will be very beneficial when you have evals, so that you become a beneficiary, that you understand that is the least costing model will help you to solve this problem most effectively. And NVIDIA's research paper does a really good job explaining that you could use a fine-tuned version of 5.2, a Salesforce XLAM model, which is really good in tool calling, but it sucks in other cases. But if you want a model which do really good tool calling and tool calling router, this is good. And SLMs are actually very cheap. And a good example would be grok.com, GROQ, where they have deployed a lot of SLMs for a fraction of the price. And
Craftsman, what you're describing here is like the optimization again of the graph and getting more bang for your buck and getting faster responses. When I'm not sure if you had a chance to look at that BMSSP that I've been all excited about this week, but that algorithm, and I just put out my WASM this morning, that basically would optimize this exact area and problem that you've been describing. And I think that what you're telling us is that there's this kind of connection between performance, cost, and speed. And right now it's like the CAP theorem: choose one but not all. And are you saying that we can potentially solve all three of those problems?
Yes, all three of them with little more time and investment. That if people spend more time, understand what deserves the best and what deserves the bare minimum, you actually can 100x your cost. Because like, imagine you use Sonnet and you realize that you don't need Sonnet to do 1+1. You can have a 4.1 mini to do that, or 4.1 nano. So the thing is, a lot of agentic tasks do not need Sonnet's capabilities. And that's my belief on how you could actually do a lot of cost savings in this entire journey, right? So this is just one thing.
Yeah, so Craftsman, we should probably chat in the next week. My biggest concern is exactly what you're describing with my latest Serafina integration for Flow Nexus. And my concern is I basically created a meter that is essentially the cost of that request plus a bit of markup. But the challenge I have is essentially I'm hoping to give like kind of an initial free period to figure out how to use the system. So there's like this success penalty that will likely potentially kill me, and I don't want to have to go talk to a venture capitalist, because you guys know I loathe venture capitalists. So you've literally described the exact problem that I'm currently pondering.
Yep. Also, probably as a person who has built a lot of agents, right? I'll just say one thing: do not believe prices. I'll just give one example: is Gemini 2.5 Flash and Gemini 1.5 Flash. Um, Gemini 2.5 Flash is really verbose, insanely verbose. And you think you're saving a lot of money because the token price is cheap, but since it is so insanely verbose, you're actually losing money unintentionally. And this is where you have to be very careful with prompting as well, because even GPT-5, if you prompt it really well, saying that do not be verbose, it actually does a good job. So I think this is also like a science of, I won't say it's a science, it's some tokenomics and a little bit of smart prompt engineering when you're building enterprise grade agentic applications, when you want to run at extremely low cost. Because I'm in a mission where I want to run an enterprise application at under $20 a month, where I'm having LLMs as a service, which I'll be giving more details soon. But in that discovery process, I found this thing is that we are usually very, I wouldn't say we are quite lazy in this optimization journey until unless when your accountant comes to you.
Yeah.
And that's when you realize like shit, it's hit the fan.
Any comments for Craftsman on his thesis here?
This is Dennis. Please forgive me for interrupting. I was trying to raise my hand, but I couldn't find it. Really quick, the point you were raising about when you use open source large language models, the initial cost, and I found this out when I used to be a product manager over at Red Hat. So Linux was free, but it cost you time and effort to learn how to run it. So what I'm seeing is that with large language models that are open source, the initial cost to get it is low, but the cost that you incur when you actually run it because it's not efficient ends up that you end up spending the same amount of money as if you had to get the regular model.
More. And if you look at the economics of when you run an open model at scale, and like running it locally on your laptop doesn't cost you anything. But when you suddenly have to deal with hundreds, thousands, or more users that are working concurrently at the same time, mix in swarms, and it's way more expensive. And you can tell that these large providers are operating, to Craftsman's point, at a substantial loss because there's no way for us as individual hosters and operators to compete on a kind of token cost at anything beyond a few hundred users. So because it's not a linear increase in cost. There's like almost an exponent at a certain level that goes from cheap to just ridiculously expensive. So for most apps, it's always cheaper just to use the subsidy of Claude or OpenAI.
Dennis, to your point, also right. I 100% agree. This learning curve. I think one comment would be is it highly depends in certain aspects that if a person's hard. So when you're talking about 100, 200 users, I would agree that whatever you say is true. But the thing is, we are playing a perception game. We think the actual cost is decreasing, but the problem is we are in a FOMO loop of we want to only use the latest model, and the latest model is always going to be expensive. But you could actually use a model 2 generations older. I could take an example of phones. A iPhone 16 will almost have the same specs of iPhone 14 or iPhone 15. You'd literally have a negligible amount of difference, but you actually have a very big difference in price. And I think that is the perception. You could use a GPT 4.1 mini nano. I'm doing a very big effort on to democratize models where you don't need to have a learning curve. Like if I know I'm using a Quen model, we'll automatically load and the package I'm working automatically load the best Quen practices into the prompt system so that you don't need to waste your time prompting. And also we have inbuilt JSON repair systems, automatic MCP repair systems, so that while I do agree open source models are really bad in MCP tool calling, because I would treat MCP as tool calling in open source realms because they're not fine-tuned specifically for MCP, right? But I think open source does deserve an opportunity. They just need a lot of more post-processing on top of it, which is algorithmic and heuristic, which is not at all difficult because a lot of these things have been coded for last two decades. So I'm in that effort there. Anyone just can use any LLM in the world to achieve the same thing without you worrying having that learning curve. So that's my future endeavors and efforts, which I'll be doing so that it actually stays true to this blog.
And to be honest, the other thing I would point out, and this has been a great sort of overview, by the way.
This meeting is being
Use
recorded.
spot instances from things like Rackspace and AWS and wherever else you get these spot instances to run a distributed swarm, if you will, of LLM endpoints. And that dramatically reduces your cost by, I think, sometimes up to 99%. And that the swarm methodology is particularly well suited for that kind of, random failures, right? Because it uses I use the Byzantine sort of fault tolerance structure, which is basically how like Ethereum and other sort of crypto networks work, but then apply it to the swarm itself, which works perfectly there. So you're basically getting whatever current instance of the GPU is available for that request. Guy, you have a comment?
Yeah, I think one of the underutilized resources that people have sitting around, I have a couple sitting around here, are old cell phones. And if you put a custom OS on that, a lot of them have NPU capabilities built into them, 8 gig to 16 gig of RAM. You could actually run a fairly decent model on that, and people could do a lot of stuff for free. So instead of having your service, you pay for the service, it's like, okay, you set this up and maybe you do handle some of the offline storage and stuff, but you're not paying the cost of the LLM. And there are a lot of other, like Orin Nanos and stuff like that. There's a lot of technology that won't run huge models, but we're starting to see, $3,500 AI computer that can run a very large model, right? The whole DGX Spark is going to be very disruptive, and you're going to start seeing people be able
Come,
to run.
Jenny, up quick. No, sorry.
Yeah.
Come
Sorry guys,
Hey, you have a
mute
hot mic
yourself.
there.
Yeah.
Oh, I know. Yeah. I can't
okay.
wait.
All right. Sorry, guys. Guy, I 100% agree. You've literally outlined this thing that I've been trying to build. So the ability to leverage each of these random pieces of CPU, which is essentially random electricity, from my vantage point, and then combine them using some kind of network that allows for communication. Is that what you're kind of describing in that concept? Oh, did we lose?
Yeah, you kind of have a pool of resources that you can assign any LLM to. And like for me, like for home control, like I have a host that runs Home Assistant. I can run a text to speech and speech to text model on those. I can run, basic AI that's fairly intelligent that can actually make home automations. And so there's a bunch of things you can do locally. And what you wanted to be able to do is take a collection of assets that you already have for a lot of people and magically put them into this pool of resources you can use for your personal private AI, right? So yeah, I think it's a lot along the lines of what you're trying to do with and have done with some of the Swarm stuff you're doing, but just a different source of assets.
I also got, by the way, guys, love to get when I get these chips in my hand. I want to get you one of them to fool around with. You're the guy for that. Pun intended.
Awesome.
Yeah. So yeah. Actually, while I have you, what have you been working on lately?
I've been working on, for my day job, getting AI adopted at work. So really a lot of autonomous coding, more so with root code and dev containers and stuff. Haven't got people to jump to Claude Code and Claude Flow yet. I think enterprise resistance to some of that, but personal projects, swarming drones, Home Assistant, financial programs, a lot of different things. I have like 47 projects in flight. So it's when some of those get mature, I'll show them on here.
Yeah.
Home Assistant will never mature, though. It's just a perpetual hobby.
Yeah. Speaking of, there was a project I worked on. You guys know I get these random hour projects. People show up, solve a problem, and there was a particularly interesting one earlier this week. There was an aerospace company, and they were struggling to create a suborbital management and relay system to sort of orchestrate essentially a swarm of microsatellites in orbit. Literally, and they're like, and apparently the guys in the office, and if you're on the call, I'm not going to share too much, but apparently the guys, were not convinced that all the things I could do was possible. So skeptics, I get those, I get the skeptics, but basically within the run of an hour we built it, and it was rudimentary, needless to say, but minds were blown, and that speaks to sort of the the capability of the systems, and it got me thinking earlier this week, like the things that we're doing now that I'm almost taking for granted on a daily basis are just beyond comprehension. Like once you sort of crack you can build anything if you ask the right questions. It becomes just a matter of conjuring this stuff out of whatever. Anyway, the reason I mentioned that, I know Guy, you've got a background in that space as well, so it just occurred to me. Yeah. So, oh, John, you have a comment?
I was just gonna say, like, on the local side, I think I mentioned this before to the group, but like, if you take and combine a BM25, which is a statistical, like, keyword-based ranking search, with like an Obama embed or Olama, not Obama, Olama embedding, like neural embedding model, those two make a really, really powerful RAG system for any local that you want to do. We actually have one that we built specifically for government use on air gap systems. And with the reasoning models, you can do tool calling because they're built for that and use them to layer different types of reasoning across search functions. So, like, have it go in, use the BM25, use that information to then use the embeddings, and then do that cycle 2 or 3 times, and you come back with really, really powerful, accurate information on, whatever documentation you want to hand it, and that can all run on a local upload. Or you can use it off of like information you have on your local computer, right? Push it into the files, let it use a file system or wherever you store your documentation. And I would definitely say, like, as far as having, it even works great for code. Like, if you want to take the OSS like 20 bill model and have it code really well, give it a repository of code to search for and use as information. And obviously purpose design the agentic MOE that for that purpose. It may take a little bit longer to actually go and code, but the code that it puts out is going to be extremely accurate. If you want to get fancy, add a ability for it to go use the web and troubleshoot, and it's really, really powerful that you can essentially get like almost, I would say, not quite Claude code level, especially around speed, but like quality of code, you can get pretty close.
You tokenize the string for BM25.
I'm sorry?
How are you tokenizing the string for BM25?
I don't even tokenize it. I just push it back straight to the LLM.
It's a re-ranking model, so it accepts a list of strings. It accepts a list of strings. So you just need to pass strings. Internally, it'll do the embeddings and then perform the re-ranking against the input query.
So if you guys haven't checked out the latest Rue code, on the bottom right corner, there's a little database thing. If you click on that and enable quadrant, it'll do a RAG indexing of your whole folder, whether that's source code or whatever. And it makes it really easy to do RAG stuff. You can run Quadrant locally if you want, or you can use their online service, but pretty amazing.
Yep.
Those of us that are slow, could you put a link to that in the chat?
Yeah, wait, I can actually I can show you guys. And by the way, the latest updates to Rue are spectacular. They've been on a bit of a run over the last 2-3 weeks, and their releases are just getting better and better. I've been using it with the Claude Code integration as well, which basically it makes it free. And I bounce back between Claude Code and Rue Code. So basically, Rue Code acts as my kind of tester while I'm building in Claude Code, and the two play off each other particularly well. The new database feature that you can actually tie into that directly using Claude Code. So basically, point Claude Code at that database and say, save all my hooks or actions and other things into that database, and then both systems are then communicating with each other.
Yeah, so what you'll see is like requests, like if you change something, it'll go, oh, and did you want to change that in these other 6 files? Because it knows the whole database. It's actually really cool.
Yep. I was gonna say, Rob, based off of a lot that neural diversity stuff that we were talking about the last time. So I found it really powerful to use GPT-5 and Claude Code or Rue or whatever you're using, sort of like you're talking about, but do it based off of that neural diversity. So essentially have them doing and checking each other. And GPT-5 absolutely looks at code differently, and code's completely different. So between the two, you get this really sort of like balance of power where they're calling each other out and actually fighting over coding approaches.
You'll notice that is really well said because and I think I showed briefly that yesterday when I showed the difference between doing the deep research in ChatGPT and then taking the deep research and implementing it with Anthropic. Now, what's also interesting in that scenario, and was part of the inspiration when I saw that happening, I'm like, well, that's where the MCP really plays a big part because I can get the MCP now to directly output from ChatGPT, but orchestrate using Claude Code, and it creates this kind of dichotomy between the two.
You've gotten Claude Code to be able to use the NVS Code extensions for GitHub instead of just going direct to their API calls?
Yes, I have, and I do this all the time. I use the MCP, the GitHub, the official GitHub MCP, and then I just add it to Claude Code, and then I update the Claude.md, and I say use the MCP for all GitHub related activities.
But I'm talking about using the models from GitHub Copilot. Have you done that?
That gives you access directly through the CLI. Yeah.
Okay,
so once you have the MCP in place, you essentially have not free, it costs, but easy access to all the services GitHub offers, including models and pages if you want to publish a page, whatever things that they've exposed in the context of their system are all exposed through the MCP now.
And I saw somebody put Perplexity in chat. Like I do the same thing with Perplexity Labs, bouncing between those or leveraging Perplexity directly within like an MCP or a call within the terminal. But it's really it's interesting, especially with I think Rashab brought up Devin earlier. So we've had a license with Devin and we've been working with that crew for a while, and they started adding MCPs and a whole bunch of other things that you can do. When you start adding the ability for it to go out and debug and purpose build those tools and actually say like, hey, you're allowed to be wrong 3 times. If you're wrong 3 times, you automatically have to go out and use a perplexity search, but you're going to look for socials and you're going to look for forums where they're debugging code. And that's like your approach. It starts to get really, really good.
Be careful. I've been able to do prompt injections really easily with that in my testing. So when I say to go search the internet, then I created a gist with some false information, and it basically acted as a kind of vulnerability injection, and it was trivial for me to make that happen based on that kind of 3 strikes and go search the web. So what you really need to make sure when you're sort of arbitrarily getting it to research, you need to have some form of validation that what it's getting isn't vulnerable in some way.
Yeah, I think our biggest thing that we do is there's sort of like a embedded red team that we built into a lot of our code. So when anyone's sort of like done with what they're doing, they can ask the red team, and it's an agentic system using Claude Code, sort of working similar to how Cloudflow works, but it's just red teaming. And it goes and rips the code apart and starts working through and like evaluates with different focus areas. But yeah, that's a good point. Like code injection is pretty bad right now, or any type of injection, because it's everywhere.
The biggest issue you have with code injection, and I see it because I've become somewhat popular with a bunch of my libraries, is there's blind trust in almost every library that you install. Like, so you're going on to my repos and you're assuming I'm a good guy, that I'm not going to do anything bad, and it's open. So if you want to look at it and figure it out whether I am or not, you can do that. But what it appears is most people don't. And it's the most people that don't are going to be injecting all kinds of craziness into their environments with never knowing that it was even there. So yeah, your red teaming idea is perfect. Max, you got a comment?
Is there a library for that somewhere?
We have not put that one out. We have another one that we put out for free called Attributor that I can link, but it essentially does the same thing, but with vulnerability management. We have not done the red team.
Also, I think Splix has an open source screener, agentic screener.
There's so many right now, especially even like free use within even paid systems. We use about 3 different ones for vulnerability and red teaming on top of what we build into the code. And between all of them, it's a headache because they're identifying almost too much to keep up with. And we're really only attacking like the highest vulnerabilities at any given time, like very highs or highs. But there's honestly a lot of repos out there with guys doing this. I'll look for a couple that we've favorited.
That's very helpful. The moral story, and this is, you guys saw that there was a massive Claude, some sort of hacker thing that they announced a couple days ago. And the issue you have with these systems is to do that security vulnerability assessment and potential fix is exactly the same thing you're going to do to exploit someone else's site, right? So it's going to be a challenging area right now as we go forward, because there's basically two sides of the same. Max, you have a comment?
I was just going to ask. I understand using the GitHub MCP for things like I think it's the submit a task to Copilot, because I don't think you can get that with the CLI. But for everything else, is there a specific reason not to use the CLI? And like sorry, you say?
Go ahead. Sorry.
Just because my thoughts are, I would rather, given that the GitHub CLI is like in the model weights, it knows how to use it without any specific instructions. I would rather save those, like, I think it's if you enable all of the tools, it's like 20,000 tokens. I'd rather use those tokens for either a different MCP or like instructions. And the same for things like AWS. Like if AWS has a CLI tool that is in the weights, surely it's more token efficient to use that and then something else for the MCP, or use a different MCP.
100%. I think, and if you look at the tools that I'm building, I always have CLI and MCP equivalents for all the tooling that I do, so they can be invoked either way. And for a lot of things, just invoking the CLI is easier. It doesn't require the challenges sometimes you have when navigating the verbosity of an MCP. And so it depends what you're trying to do. So if you're doing hooks, if for example, in Claude Code, you're doing a hook at the end of every task. I'm just using MPX CLI. I'm not using the MCP itself, because it's way easier just to pass the variables as arguments to, or commands, or whatever it needs to do as part of the hook. So it makes a lot of sense, and it's as you point out, it's cheaper.
Oh, just in terms of how many tokens you use?
Yeah. So
not having to add it, not having to have the MCP as part of the system prompt. Yeah, completely.
I think we lost him again. You back, Roof? Your face moved.
Oh, it's frozen again. Log in, log out. We're at the sort of the open section. I know, Dragan, you had something that you thought you might like to share, give a little demo.
Yeah, but after all these demos, I'm
some neat stuff this week for sure.
Yeah, the guys put the high, the ladder is high right now, so
yeah.
But I will try to introduce myself first to the group. Like I'm currently vice president of quality engineering in one American Serbian startup company that does like electronic lab notebook and laboratory information management system digitization for chemical industry mostly. And I got drawn to this Agentic Foundation group and started following all your work. And a month ago, I tried like to see like a small experiment if I will be able to generate the whole application. And the application that I did generate in the, let's say, couple of cycles of using different tools is open sourced. It's named Sentinel. This is something that I got from asking Gemini 2.5 Pro to generate me like a PhD specification, like a blueprint for agentic AI-powered app testing platform. But I pointed it to most of the things that Ruv is sharing. So I use his Spark framework. Most of the things here are relying on his Swarm Foundation for ephemeral testing agents. So, and what amazed me is that at the end I have like a application where I can upload a specification. I can generate different types of tests where agents are being spawned, and yeah, also to test like performance improvements comparing Python implementation of agent and Rust implementation of agents. I first did the implementation using the Python code, and then ask it to rewrite in the Rust, so we can see that almost like in average like a 19 to 20% faster test case generation is gained with using Rust as a language to write the agents.
Really, direct side by side.
Yeah, so it was like a eye-opening at the end. It's okay, you can use Python for a lot of things, but if you want something really fast, in this case Rust proved. I don't know even what to show after all these things, but I'm trying to achieve here. And I started also like now 6 or 7 parallel projects with ideas spawning and specifications are ready. I'm trying to use the same approach that I'm following here during the AI hackerspaces, and watching you guys how you're approaching things, and you're just learning and grasping things. And what I would like also to do is spread this word here in this region of world. So I'm from Serbia, but I will try not only I will try to connect with colleagues from the region, from Balkan region, from Croatia, Bosnia, Romania, Bulgaria, and see if we can make some Balkan chapter here in this region.
Yeah, that would be great, Dragan. Any questions for Dragan and this project he's built out?
I'm disappointed that I missed it. My internet went down for exactly the length of time that you did your presentation.
Oh, you can watch it later.
Okay, yeah, but
yeah,
we spoke a couple days ago, so I was excited to see the update.
Okay, I can show it again. So
just quick. Yeah,
just a quick.
Mm-hmm.
So application is for generating test case based on the uploaded YAML or JSON file of the specification. So, and different types of agents are implemented using most of your approaches, like the Rufan, Wasm, Spark as like a development approach. So specialized agents for different. I started like let's start with the basic things, but I already have some specifications ready to start growing this into some omni testing agent, let's call it like that. So this is just the beginning, and I'm trying to see how I can help the first Cloudflow, now Flow Nexus, maybe with adding some more agents that will do the verifications and validations of things. As we all notice that they can lie, they can say something is finished when it's not. And I just experienced like 3 times, are you sure, did you double check this, and then returning in cycles.
I love it. I think that what you're showing is hugely useful. I'd love to do a like security challenge and have a bunch of us compete to see who can solve the problem the best in the shortest period of time.
You also like missed, so this was like my test to check the behavior between implementation of agents in Python and Rust, and you can see
capture the flag?
It's really
Agentic capture the flag. Yeah, exactly. This is awesome. And it's, I know this is going to sound very full of myself, but it's very rewarding to see other people using the crazy ideas that I've dreamt up. And when people say like, why do you create and give away all your stuff? I think that right there is exactly why I do it.
Yeah, Fatih, you have your hand up. Sorry,
Yeah.
Vlad.
Yeah, just some to share. I thought this discussion with the Rust versus Python. So I was actually it was my first try at the Claude Flow like last week, and I needed to develop a tool that has to run on every possible things with minimal setups. And I tried both Rust and Go actually won because with the Rust it still has a lot of dependencies on.
So I can try to rewrite it in Go. So let's have like
yeah,
three
it
results
depends
in
what you're
parallel.
doing, but I found the Go is the best language if you want to develop something that you just give like one file and it just runs because it has zero. I mean, the
Well,
pattern and
it depends. It depends. If both can compile to a WASM, but ultimately my compilation isn't Rust. It's the WASM with some kind of JavaScript UI
but
interface to it.
then you need npx and node setup and everything. With
Yeah,
Go
that's
you need like zero.
Yeah,
like, you just
so it depends if you're Go still has dependencies depending on when you're running it, but it depends on how you're delivering it. Now, if you're building this thing for your own purposes and distribution isn't a concern, then npm and npx style distribution doesn't matter. You control the distribution.
No. Yeah, but I have a zoo of servers, including some FreeBSD. Like, so there is a lot of very old like operating systems you cannot upgrade, and some of the FreeBSDs, some of the node would just not run on them. Like in a Python would not run, so that's why I was going in that. So the Cloudflow actually set up very bizarre setup with because it basically. So the problem is C library, because if you Rust still depends on it. So in glibc, like if you like launch it, like if it's a very old operating system, it would just not run. And the Rust, I mean, the Cloudflow actually came up with this whole bizarre system of using something called Muscle, which is alternative to like C library, but it was very clunky to build and compile, and Go just works like everywhere.
Yeah, it's the right tool for the right job. The other thing I point out, if it's taking you down a weird path, that likely has to do with your initial specification. So what you want to make sure you avoid is the research and build it in one sort of go. It's a bad plan.
So my setup was actually run 3 separate instances of the Cloudflow, and I mean first I asked it to do discussion what's the best tool, like, so I did not actually choose the tool to use. And then I ran 3 separate instances of like one was running doing Rust, one was doing Go, like one was doing like Python, and I just got the end result and like basically evaluate and see what I.
And by the way, I recently did a project in Go as well just because I wanted to. And the reason I don't do more in Go is back to distribution. I like that Rust has crates and as a mechanism for discovery and delivery, and half the stuff I just want people to get in their hands. Go is kind of fragmented. Like, where do you discover Go apps? There's a bunch of separate sort of unconnected repos.
Guess it depends. But that's also like that's the reason lots of DevOps tools are written in Go, like all the Terraforms and Packers, and because of the ease, like of the single file, basically. Like here's the file for you, and it has everything.
No compilation as well.
I mean, no, there is compilation in Go. Like it's the same as Rust.
It's just I mean, it compiles faster, or it's not noticeable.
I didn't see any noticeable difference. It was about the same.
Okay. Yeah, well, love to see a little demo of that sometime. See how you did it.
Sure. Yeah. I mean, I'm actually kind of reevaluating all the tools right now, so maybe I'll.
No, never time. Guys, we gotta wrap up pretty soon, but I think Fatih, you had a question.
Happy birthday, first of all.
Thank you.
And I have actually built something similar a month ago called it. I mean, I actually talked about it a few weeks ago. Code Quality Governance Sentinel.
I heard that talk of yours, at the moment when I was, working on this. So it was like, oh my God, he's working on something similar. So
collaborate.
So anyways, I mean, I can actually show you. It runs on the Claude Code in the MCP. I mean, I integrate it. I don't know if I can manage because I'm in a browser. How do I?
There should be a share. There should be a share button somewhere.
Share button.
Green middle. I never use Zoom in the browser, so I'm not familiar with.
You need to move the
I'm
mouse.
using an Arch Linux system, so I couldn't get it installed because it uses an Ubuntu-based, binary. So the only way I could join is the using the browser. So, anyways, I mean, it integrated into the MCP in Cloudflow, and when I run validate, and it goes, runs validation using 55 agents with various, capabilities, and then it gives you like a through report. I mean, actually, I can share you maybe one of the reports after. I can email you, but so far I think I'm like limited with the browser. Oh, here we go. Share screen.
We found it.
Found it. Okay. Yeah, can you see?
Yes, looks good.
Okay, so I'm just gonna hit enter. You see, there's the CGS colon CGS validate, and there we go. I actually put on the GitHub this one, and but I have compiled, and these are like binaries running.
Nice. And what are you running right now? You're running a ML training?
Yeah, I'm running a validation on a crate I created on adaptive temperatures scaling with conformal prediction, like for cryptocurrency prices prediction algorithm. And so it is running validation on that crate right now.
Nice.
If there's any like math random and like, the Claude bullshit, basically.
Yeah.
Yeah, the bullshit detector is on.
Yeah, bullshit detector. Like there are 49 agents, and then there are like 5 of them and the queen.
So what I would suggest you do as the next step here, you should go grab the E2B sandbox capabilities and add those here, and then that'll allow you to add sort of a agentic persistence to any of your trading components. So if you need those agents to essentially continue to train, learn, and execute on what they're learning, the E2B sandboxes are great for that because you can sort of have that swarm operating continually independently of Claude code.
Hey,
wow.
You mentioned it.
I think I will do that next. Yeah, that's what it does, and it just.
I've got the code for you for anyone signed up for my NeuroTrader. Send me your GitHub, and I'll get you in the repo. But in that repo,
thank you.
You'll see that there's an E2B connector that that includes MCP. So you can do all the same stuff I was showing you with like my other swarms in MCP mode, but it also gives you that persistence.
Okay.
Yeah.
Okay. So yeah, that's what it does right now, and I don't know how long it's gonna run, but I don't want to, of course, take much of your time here. So
trading, to be honest, I think trading is one of the best agentic use cases I've dreamt up. Well, I didn't dream it up. I've been mastering. It's just there's so many vectors for how it can operate, and it's just like a playground of learning how to do agentic engineering with lots and lots of data, because there's like so many different feeds and places to look and decisions that can be made. It's just it's just a fun sort of place to discover how and what you can do with agents.
Yes, definitely. I've been exploring trading and agentic trading ever since I started using Claude. And first I tried to build frag trade strategies using Python. And then, Python has a lot of like latency issues. So, it's not good for like high frequency trading. And then, like you have to have like a person, like the way, how an agent should behave like a broker. And so, in order to do that, you have to have like a very large library. And doing all of that in Python is just like, almost impossible. I did a lot of optimization, making sure that, there's NumPy optimization for mathematical functions and vectorization. But still, I think Rust is the way to go, because Python is not good for trading.
It depends. Well,
maybe like
real-time sort of introspection. Once it's running, it's fine. The issue you have with Python is the time it takes you to start the app if it's transient. Ephemeral processes are slow. But once it's running and you're like stream analysis or something, it's more than adequate. But the part where you need to make like instant decisions, like is this good, bad, or otherwise, in like a trade or sort of introspection of the real data, if you make that a sort of Rust-based thread, then you can get that sort of nanosecond decision that I was talking about earlier.
Exactly.
Yeah. So using that latest algorithm, I was able to go from 1.9 milliseconds for a really basic sort of decision, like a couple different stocks kind of thing, and I was able to get that down to 0.002 milliseconds. I don't even know what that is. I think I need to use some calculus to describe it, but it's like substantially faster. And you can do much. So once you have that level of sort of speed from a temporal sort of point of view, you can do a whole lot of things concurrently, right? So not only can you look at, baskets of, in that case would be like 2 or 4 stocks and how they relate to one another. You can do that, but you can do that for thousands at the same time, and you can literally just use your CPU to do it.
Yes, that's true. That's true.
Yeah.
So with with Python, you have to do a lot of like the calculations on GPU, and that's very costly.
Yes, exactly. So I don't GPUs, as you can tell, I love GPUs for certain things, but for if you're cheap and you want cheap and fast, it's not necessarily the way to go.
Yeah. Exactly. Also, for the number crunching, I don't think anybody's beat Fortran still. Like, I think it's because if you look at what's inside of NumPy and all this machine learning things, it's all like Fortran underneath. And if you're doing another thing, it's all the languages that have just-in-time compilations, like Julia and stuff. What they do, I mean, they work well if you do the same thing for a very long time, because they look at your code and they constantly recompile. Like, so
yeah, exactly. It depends on what you're doing, and it's a mix and match. That's the best approach, and one of the best reasons to use agentic code development is the fact you're not locked into any particular language or environment or architecture. You can dream up new ways to mix and match the best for the problem you're trying to solve. And that's in the old world, that wasn't feasible because you couldn't just conjure these systems by asking a couple questions. So we're in pretty much uncharted territory.
Yeah, that's actually like when last week I actually don't know like much of the Go or Rust. Like I was able to develop a thing because I had a Python prototype and said just to implement this and like these other languages, and it worked. Like
yeah. All right. I'm probably gonna have to wrap it up here shortly. Any last comments, questions? This is your last call.
We'll be continuing this conversation, I think, in the Agentics Discord link in the chat. Otherwise, enjoy your weekend, Ruve.
Yeah, thanks. I'm going to attempt to unplug a little bit. I have some work issues I need to, I work too much. But anyway, this week I'm going to try to unplug a little bit. And again, as always, appreciate everyone who took the time to tune in, show, demo, all that stuff. This is always the highlight of my week. We've got some events coming up. I think I saw Ben's mentioned London. He's organizing another one, and there's talk of other locations. So if you're interested in having a local meetup, reach out to Rob or some of the folks here, and we can probably make it happen. And we'd love to help in any way we can. Agentex.org if you're interested in supporting us. I know we've been working our way to make the site more valuable. There's a community.agentex.org site you can check out that Brad and crew launched a couple weeks ago. And as we're a nonprofit organization, if you feel like helping support us, sign up for a membership. I know even if there's not obvious the value proposition, it helps keep the lights on, and we have no real other income other than your support, etc. So anyway, that's it. That's all I got for today. It's my birthday. I gotta go chill on the beach or something.
Happy birthday, buddy. Cheesecake and fishing.
Happy birthday.
Yeah. All right. Thanks.
Bye.
Thanks.
Good day, Rob.
Thank you. Bye.
Bye.